China just built a construction machine that shocked American engineers, but it's not just one machine. You're about to witness 15 pieces of equipment that are rewriting the rules of what's physically possible. From cranes that lift 20,000 tons to automated systems that lay railway tracks with millimeter precision, these machines operate at the absolute edge of engineering capability. We're talking about equipment so powerful, so advanced, that it's changing how the entire world builds infrastructure. And the first machine on this list can lift the equivalent of 3,000 elephants in a single pull. Taisun Gantry Crane. Picture this. You're standing at a shipyard, looking up at a structure that spans 436 feet across. This is the Taisun Gantry Crane, and what it can lift will make your jaw drop. 20,000 tons. Let that sink in for a moment. That's the weight of 200 fully loaded Boeing 747s, and this crane hoists it into the air like it's nothing. But here's where the engineering gets absolutely insane. Most cranes use a single hook system. Taisun uses two massive hooks working in perfect synchronization. The challenge? Distributing 20,000 tons of force evenly across both hooks while keeping the load stable 260 feet in the air. One miscalculation, one imbalance, and you've got a catastrophic failure that could destroy an entire shipyard. The solution is pure engineering brilliance. The hydraulic system pumps fluid at pressures that would explode conventional equipment, while computer systems monitor every millimeter of movement across that 436-foot span. When Taisun lifts an offshore oil platform or a complete ship section, it's not just moving weight, it's performing a ballet of physics, force distribution, and precision control. This is what happens when you push lifting technology to its absolute limit. But lifting 20,000 tons is only the beginning of what these machines can do. Sany SY500H excavator. Now you're looking at 50 tons of pure excavation power. And the Sany SY500H doesn't just move dirt, it devours entire landscapes. This machine's bucket can swallow nearly 4 cubic yards in a single scoop. And when you're watching it work, you realize you're seeing something that operates on a completely different scale than ordinary construction equipment. Here's the tension. How do you generate enough force to rip through solid rock and compacted earth, cycle after cycle, without tearing the machine apart? The hydraulic system on this excavator generates pressure so intense that the arm's breakout force exceeds 70,000 pounds. That's enough to crumble concrete, snap tree roots like twigs, and penetrate ground that would stop lesser machines cold. But raw power is worthless without control. The SY500H's hydraulic flow system adjusts pressure thousands of times per minute, giving the operator fingertip precision while wielding that 70,000 pounds of force. Watch it work, and you'll see the bucket slice through earth, lift, swing, and dump in a rhythm so smooth it looks choreographed. The cycle time dig, lift, rotate, dump, return happens in seconds. Hour after hour, the machine maintains this pace, moving hundreds of tons of material while the operator sits in a climate-controlled cab with joystick controls that respond to the slightest touch. This is excavation elevated to an art form. And speaking of precision, the next machine takes accuracy to a whole new level underground. XCMG XZ960E Horizontal Directional Drilling Rig. You're about to witness something that seems impossible. Drilling a tunnel hundreds of feet underground without disturbing the surface above. The XCMG XZ960E makes this happen with 960 tons of pullback force, enough power to drag a fully loaded freight train through solid earth. But here's where it gets absolutely wild. This isn't just about brute force. You're steering a drill bit through rock, clay, and obstacles you can't even see, sometimes under rivers, highways, or city streets. 1 degree off course, and you've missed your target by dozens of feet. The tension is real. How do you guide something with 960 tons of force through the earth with pinpoint accuracy when you're completely blind? The answer is a guidance system so sophisticated, it tracks the drill head's position in real time using sensors that communicate through the drill string itself. Meanwhile, a mud circulation system pumps specialized fluid through the bore, cooling the drill bit, stabilizing the hole, and carrying away debris, all while maintaining precise pressure to prevent collapse. The drill bit? It's engineered to pulverize rock, slice through roots, and navigate around underground utilities without breaking stride. When the XZ960E punches through on the other side, exactly where it's supposed to, it's pulled back through, installing utility lines, fiber optic cables, or pipelines in a single continuous operation. No trenches, no torn-up roads, no disruption, just pure underground precision. But if you think drilling underground is impressive, wait until you see what's reaching into the sky. Zoomlion R2720 Tower Crane. Now look up, way up. You're staring at a tower crane with a working radius of 886 feet that's nearly 3 football fields of reach, and it's operating from a height that would make your stomach turn. The Zoomlion R2720 doesn't just build skyscrapers, it defines them. Here's the engineering nightmare. At 800 feet in the air, even a slight breeze becomes a violent force. The crane has to lift tons of steel and concrete while compensating for wind load, the building's sway, and its own movement. And here's the real tension. This crane doesn't get assembled on the ground and lifted into place. It climbs. As the building grows, the R2720 climbs with it, using a self-climbing mechanism that's essentially the crane lifting itself, story by story. Think about what that means. The crane has to support its own massive weight, the load it's carrying, and somehow hoist itself higher using hydraulic jacks that push against the very structure it's building. One failure in this system, and you've got tons of steel plummeting from hundreds of feet up. But the R2720's climbing mechanism is engineered with redundancy after redundancy hydraulic systems, locking pins, and safety catches that ensure it never falls. The control system is equally mind-bending. The operator sits in a cab nearly 1,000 feet up, using precision controls to place multi-ton loads within inches of their target. At that height, at that distance, with wind and building movement, it's not just skill, it's a technological marvel, making the impossible routine. And while this crane reaches for the clouds, the next machine proves that incredible power can come in a surprisingly mobile package. Lonking CDM863 Wheel Loader. You're watching 6 cubic yards of material disappear into a bucket in one smooth scoop. The Lonking CDM863 doesn't look as dramatic as a tower crane, but what it does hour after hour, day after day, is the backbone of every construction site on Earth. This wheel loader can lift over 10,000 pounds in a single bucket load. And here's what makes that incredible. It does it while moving. But here's the challenge. How do you generate enough hydraulic force to break through compacted materials, lift massive loads, and do it fast enough to keep a construction site running at full speed? The CDM863's hydraulic system operates at pressures that would rupture ordinary equipment, delivering both the breakout force to fill the bucket and the lifting power to raise it 12 feet in the air. Watch the cycle. The loader approaches a pile, the bucket teeth bite into material. The hydraulic rams drive forward with over 30,000 pounds of breakout force. The bucket curls back and fills. Then the whole assembly lifts. The loader reverses, spins on its axis, drives to the dump truck, elevates the bucket, and releases. 20 seconds. Then it happens again and again. For 12-hour shifts, this machine moves hundreds of tons without missing a beat. The transmission system constantly adjusts power delivery. The tires, massive rubber cylinders that stand taller than a person, grip and release with perfect traction control. And the operator has visibility and control that makes this 10,000-pound beast feel responsive and precise. But if you think moving 6 cubic yards at a time is impressive, the next machine multiplies that scale by a factor you won't believe. XCMG XGC88000 Crawler Crane, 4,000 tons. You're looking at a crawler crane that can lift 4,000 tons. And to put that in perspective, that's 8 million pounds hanging from a single machine. The XCMG XGC88000 isn't just a crane, it's a mobile engineering impossibility that somehow exists. Here's the insane part. This thing moves. Most cranes with this capacity are permanently installed structures, but the XGC88000 crawls on massive tracks that distribute its weight across the ground. But here's the tension. When you're lifting 4,000 tons, the forces trying to tip this crane over are absolutely catastrophic. One wrong calculation, one shift in the load, and physics wins in the most destructive way possible. The solution is a counterweight system that's a marvel in itself. Over 2,000 tons of steel weights are precisely arranged on the back of the crane, creating a balance point that keeps 4,000 tons from pulling the whole machine over. The crawler tracks each one wider than a car, spread the combined weight across enough surface area that the crane doesn't sink into the ground or crack the pavement beneath it. But the real genius is in the boom configuration. The XGC88000's boom can extend to over 230 feet, and it's modular, assembled on-site in sections. The hydraulic systems controlling this boom operate with such precision that operators can place 4,000-ton loads within inches of their target. When this crane lifts a wind turbine nacelle or a petrochemical reactor vessel, you're watching forces that could level buildings being controlled with surgical accuracy. And speaking of surgical accuracy, the next machine takes precision to the streets literally. XCMG XS263 vibratory roller. You're watching 26 tons of steel create the perfect road surface. And what the XCMG XS263 does might sound simple until you understand the engineering madness happening beneath that massive drum. This roller doesn't just flatten asphalt, it vibrates at specific frequencies to compress material into a surface that will last decades. Here's where it gets technical in the most fascinating way. The drum isn't just heavy. It's vibrating at frequencies up to 67 Hz, while generating over 58,000 pounds of compaction force. But here's the tension: too much vibration, and you crush the aggregate, destroying the road's structural integrity. Too little, and you get uneven compaction that leads to cracks, potholes, and failure within years. The XS263 solves this with a vibration system that adjusts frequency and amplitude on the fly. Sensors monitor the material's response in real time, and the system adapts harder. Materials get higher amplitude. Freshly laid asphalt gets gentler treatment. The drum itself is an engineering marvel, designed to distribute those 58,000 pounds evenly across its 8-foot width while maintaining perfect contact with the surface. And it's not just pressing down, it's moving. The roller travels at speeds up to 7 miles per hour during compaction, meaning it's delivering precision vibration while in motion, maintaining consistent pressure and frequency across every inch of surface. The result? Roads that handle millions of vehicles without deterioration. All because this machine understands the physics of compaction better than any human operator ever could. But while this machine perfects surfaces, the next one dominates them with sheer excavation mass. Liugong 995F. You're staring at nearly 100 tons of excavator, and the Liugong 995F operates on a scale that makes typical construction equipment look like toys. This machine's bucket can hold over 6 cubic yards, and when that arm extends to its full 49-foot reach, you're watching physics push to the absolute brink. Here's the engineering challenge that'll blow your mind. At maximum extension, with a full bucket load, the forces on that arm are trying to rip the machine apart. The torque at the boom's base is astronomical. The hydraulic cylinders are under pressure that would explode lesser equipment, and the entire excavator has to remain stable while wielding all that weight at the end of a 49-foot lever. The 995F's hydraulic system delivers this with pump capacities that flow hundreds of gallons per minute at pressures exceeding 5,000 psi. The bucket's breakout force, the raw ripping power when it tears into the earth, exceeds 110,000 pounds. That's enough to excavate blasted rock, demolish concrete foundations, and move materials that would stop smaller excavators cold. But here's what's truly incredible. Despite operating at this extreme scale, the 995F's control system gives operators precision measured in inches. The undercarriage tells its own story. Massive tracks distribute that 100-ton weight, while the cab mounted on vibration dampeners keeps the operator comfortable during 12-hour shifts of high-intensity excavation. Production capacity? This machine moves over 1,000 tons of material per hour when it's running full bore. But if you think this excavator is mobile, wait until you see what the next machine can do on the highway. Zoomlion ZT82J truck-mounted crane. 82 tons of lifting capacity, and it just drove here on the highway. You're looking at the Zoomlion ZT82J, And what makes this machine absolutely wild is that it combines the lifting power of a massive crane with the mobility of a truck. One minute it's traveling at highway speeds, the next it's hoisting loads that would challenge stationary cranes. But here's the engineering nightmare. When you mount an 82-ton crane on a mobile chassis, you're creating a tipping disaster waiting to happen. The boom can extend over 200 feet, and when you're lifting maximum capacity at distance, the physics are trying to flip this entire truck on its side. The tension is real. How do you keep 82 tons of load from becoming a catastrophic rollover? The answer is in the outrigger system. 4 massive hydraulic stabilizers extend from the chassis, spreading wider than the truck itself, creating a stable base that can handle the forces involved. But it's not just about spread, it's about calculation. The ZT82J's computer system constantly monitors boom angle, extension, load weight, and ground conditions, creating a dynamic load chart that tells the operator exactly what's safe at every position. Cross those limits, and the system won't let the crane move. The telescoping boom is its own Marvel sections, sliding within sections, extending hydraulically to full length in minutes. From highway travel to full lifting operation takes less than 15 minutes of setup. And when the job's done, the outriggers retract, the boom collapses, and the ZT82J drives away to the next site. But while this crane brings mobility to heavy lifting, the next machine goes deeper than anything you've seen so far. XCMG XR360 Rotary Drilling Rig. You're about to drill over 300 feet straight down into the earth, and the XCMG XR360 is the machine that makes it happen. This rotary drilling rig doesn't mess around. It creates the foundation holes for skyscrapers, bridges, and structures that need anchoring points reaching deep into bedrock. Here's where the engineering gets absolutely brutal. The drill bit has to penetrate rock, clay, sand, and whatever else lies beneath, while the rig generates rotary torque of over 265,000 foot-pounds. To put that in perspective, that's enough rotational force to twist steel beams like they're made of plastic. But here's the tension. All that torque is trying to spin the entire rig off its base. One loss of stability, and you've got a 300-foot drill string whipping around out of control. The XR360's solution is a stabilization system that fights physics with engineering precision. The base locks into position with hydraulic anchors, while the mast standing over 100 feet tall remains perfectly vertical even as it generates that massive torque. The Kelly bar, the drive shaft that spins the drill, telescopes downward as the hole deepens, maintaining consistent power delivery all the way to 300 feet down. But drilling is only half the challenge. The rig has to extract all that debris while maintaining hole integrity. A mud circulation system pumps specialized drilling fluid down the hole, cooling the bit, stabilizing the walls, and carrying crushed rock back to the surface. When the XR360 completes a hole, you've got a perfectly cylindrical shaft ready for concrete and rebar, the foundation that everything above will depend on. And speaking of foundations, the next machine builds them in a completely different way on the surface, and fast. Sany SAP120C8 Asphalt Paver. You're watching a machine lay a road 12 meters that's nearly 40 feet wide in a single pass. The Sany SAP120C8 isn't just spreading asphalt, it's creating a perfect surface at speeds that seem impossible for this level of precision. This paver can lay road at over 100 feet per minute, and here's what makes that absolutely insane. Every inch has to be exactly the right thickness, the right temperature, and compacted to exact specifications. Here's the engineering challenge that'll make your head spin. Asphalt cools fast, and as it cools, it becomes harder to compact properly. If the temperature drops too much before compaction, you get a weak surface that'll crack under traffic within months. The SAP120C8 has to receive hot asphalt, spread it evenly across 40 feet of width, compact it immediately, and maintain consistent quality while moving forward continuously. The screed, the business end of this machine, is heated to over 300 degrees Fahrenheit, keeping the asphalt workable as it spreads. Inside the screed, vibratory compactors are hammering the material thousands of times per minute, while tamper bars apply pressure and smooth the surface. The thickness control system uses sensors and grade references to maintain accuracy within a fraction of an inch. automatically adjusting as the paver moves across varying terrain. The hopper at the front holds 13 tons of asphalt and augers distributed evenly across the full width before it reaches the screed. Material flow, temperature, compaction, pressure, every variable is monitored and controlled in real time. The result? Roads that handle decades of traffic without deterioration. But while this machine perfects road surfaces, the next one returns to pure digging power with a twist on versatility. Liugong 950E Excavator. You're looking at an excavator that refuses to be just one thing. The Liugong 950E operates in that perfect middleweight, powerful enough for serious excavation, nimble enough for precision work. But here's what makes it genuinely remarkable. The hydraulic quick coupler system that lets it swap attachments in minutes. Here's where this gets interesting. Most excavators are stuck with their bucket, doing one job all day long. But the 950E's quick coupler means this machine can be a demolition beast with a hydraulic breaker, a precision trencher with a narrow bucket, a material handler with grapples, or a rock excavator with ripper teeth, all without a single bolt being manually removed. The tension? Each attachment puts completely different loads and stresses on the hydraulic system and arm structure. The 950E solves this with a hydraulic system smart enough to recognize what's attached and adjust flow and pressure accordingly. The breaker needs high-pressure pulses. The grapple needs steady clamping force. The bucket needs maximum breakout power. And the machine delivers each one perfectly. The quick coupler itself is engineered with redundant locking mechanisms, because an attachment falling off mid-operation isn't just expensive, it's deadly. With a digging reach of over 30 feet and breakout forces exceeding 40,000 pounds, the 950E handles everything from foundation excavation to utility work to demolition. The fuel efficiency is equally impressive. This machine does more work per gallon than excavators twice its size, thanks to a hydraulic system that only uses the power it needs when it needs it. But if you think versatility is impressive, the next machine returns to pure lifting dominance with a capacity that rivals the biggest. Sany SCC4000, a crawler crane, 4,000 tons. Again, you're looking at another machine that can lift 8 million pounds, but the Sany SCC4000A does it with one critical advantage. It assembles faster than any crane in its class. When you're talking about equipment, this massive setup time isn't measured in hours, it's measured in days or even weeks. But here's where Sany changed the game. The tension with cranes this size is brutal. Every component weighs tons, requires specialized transport, and has to be assembled with millimeter precision while you're essentially building a structure that'll handle forces capable of destroying buildings. One misaligned connection, one improperly torqued bolt, and you've got a failure point that could collapse under load. The SCC4000A's modular design cuts through this nightmare with sections that lock together with alignment systems so precise they're almost foolproof. But here's what really separates this crane: the boom configuration options. Depending on the job, the boom can extend to over 400 feet with different arrangements for different lifting scenarios. Need maximum height? One configuration. Need maximum radius? Different setup. Each configuration changes the crane's load chart, its counterweight requirements, and its stability profile. The engineering has to account for every possible combination while maintaining safety margins. When the SCC4000A lifts a wind turbine nacelle components weighing hundreds of tons to heights over 300 feet, it's performing a controlled physics experiment. The hoisting system raises the load at speeds that seem impossibly fast for such weight, yet the control is so refined that operators can stop within inches. This is 4,000 tons, moving with the precision of a surgical instrument. But all these machines have human operators making split-second decisions until now. Janghai loader. You're watching another wheel loader attack a material pile. But the Janghai brings its own engineering philosophy to the work. With bucket capacity rivaling the biggest loaders and lifting force that exceeds 50,000 pounds, this machine proves there's more than one way to solve the problem of moving massive amounts of material efficiently. Here's what makes the Janghai distinct. The hydraulic system is engineered for continuous high-intensity operation in conditions that would overheat and fail in lesser machines. Quarries, mines, industrial sites, where the loader runs non-stop for entire shifts, this is where the Janghai shows what it's built for. The challenge? Maintaining hydraulic pressure and flow when the system is generating extreme heat from constant use. The Janghai's cooling system is oversized deliberately, with oil coolers that can handle thermal loads that would cook standard equipment. The hydraulic pumps are built with tolerances that maintain pressure even as temperatures climb. But it's not just about surviving the heat, it's about maintaining performance. The bucket's breakout force stays consistent, the lift cylinders maintain speed, and the transmission doesn't fade, even when the machine is working at maximum capacity, hour after hour. The attachment points accept specialized buckets for different materials: rock buckets with reinforced teeth, coal buckets with increased capacity, aggregate buckets with wear-resistant liners. The operator's station is designed for visibility during the most chaotic loading conditions, with sightlines to the bucket edge that let them fill to maximum capacity without spilling. This is a machine built for the long haul in the hardest conditions. But impressive as that is, what comes next eliminates the operator entirely. The automated railway track layer. You're watching the future, and it doesn't need a human at the controls. The automated railway track layer is placing railway tracks with millimeter precision at speeds that human crews can't match, can't sustain, and honestly, can't believe. This machine lays track at over 1,600 feet per hour. And here's what makes that absolutely revolutionary. It does it perfectly, every single time. Here's the engineering insanity. Railway tracks aren't just metal rails on the ground. They have to be positioned with tolerances measured in fractions of an inch, aligned perfectly straight or curved to exact specifications, elevated to precise grades, and welded together into continuous sections that will handle trains moving at hundreds of miles per hour. 1 millimeter off over a mile of track, and you've got a derailment waiting to happen. The tension is enormous. How do you automate something that requires this level of precision? The track layer uses GPS positioning accurate to within millimeters, combined with laser guidance systems that constantly verify alignment. Robotic arms grab pre-assembled track sections, position them with servo-controlled precision, and lower them onto the ballast. Then the real magic happens. Automated welding systems join the rails with welds so perfect they're stronger than the rail itself. Sensors scan every weld with ultrasound, detecting flaws invisible to the human eye. But it's not just laying track, it's distributing ballast, tamping it to exact density, and adjusting elevation, all in one continuous operation. The machine crawls forward, and behind it, finished railway emerges ready for trains. What used to take crews weeks now happens in days. The system works through the night, doesn't get fatigued, doesn't make mistakes, and maintains quality that exceeds anything human hands can achieve. This is construction equipment that doesn't just assist humans, it replaces entire processes with automation, so advanced it seemed like science fiction a decade ago.